Hello friends, in this video we will discuss a problem related to kinematics. So in the question it is given that two particles A and B are projected along different directions from the same point on the ground with same speed of 70 meter per second in the same vertical plane. They hit the ground at the same point Q such that the value of range, that is the value of PQ, is given as 480 meters. Now some standard values are given in the problem and we have to find which of the following options are correct. So let us read out the conditions that are given in the problem. Just for the sake of comparison, we can draw these two conditions. Simultaneously, the particles are thrown from the same point P and they again land at same point Q. It is also mentioned that speed of both the particles is 70 meter per second. The only difference between these two particles now is going to be the angle of projection that I am assuming to be equal to theta 1 and theta 2. Also, the value of range given in the problem is 480 meters. Okay, so now let us apply the formula for range of projectile A. We are denoting both the conditions by A and B. So let us apply the equation of range for projectile A. We can write the value of range is equals to u square sine 2 theta u square sine 2 theta divided by g. The value of g given in the problem is 9.8, which on simplification will give the value of sine 2 theta to be equal to 0.96. That is, the theta will be equal to 2 theta will be equal to sine inverse 0.96, which is mentioned in the problem as 74 degrees. That is, the value of theta is 37 degree. Now since we know that both the particles are thrown with same speed and they are having same range, the range of second particle is also mentioned in the problem to be equal to 480 meters. So we can say that if first particle is thrown at an angle of 37 degree, then the angle of projection for second particle has to be 90 minus theta 1, that is 53 degrees. Let us now find the ratio of the time period of both the particles. We know that the time period is equals to 2u sine theta by g. So the ratio of both the time periods will be sine theta 1 divided by sine theta 2, that is sine theta 1 divided by cos theta 1. Since the sum of both the angles is equals to 90 degree, that is tan theta 1, which is equals to 3 by 4. So the option A is incorrect. You can see that the option A, where the ratio is given to be equal to 4 by 5, is incorrect. Let us now check for the correctness of option B. We have to find the ratio of their heights. Since their velocities are equal, that since their speeds are equal, that is the magnitude of their velocities are equal, the ratio of their heights will be equal to sine square theta 1 divided by sine square theta 2, which on putting the desired values of theta 1 and theta 2 gives us the value of 9 by 16. That is the option 2 given is correct. Okay, so let us now check the expression C that is given. We have to find the ratio of their minimum speeds. We know that both the projectiles will attain minimum speed at highest point, and at highest point the speed is equal to u cos theta 1 for first particle and u cos theta 2 for second particle, which on putting the values of theta 1 and theta 2 gives us the value of 4 by 3. Now as for option D, we have already mentioned that the value of theta 1 plus theta 2 is equals to 90 degrees, and we have to find the bisector of the angle between them. So we can clearly say that the bisector of the angle between them will be equal to the value of theta 1 plus theta 2 by 2, that is 45 degrees. So this is our desired result.